So this question asks us, what is the fastest speed that a car can go over this hill without losing contact with the ground? So here's our hill, and it has a radius of 55 meters. We want to know the fastest speed we can go over this hill without using it like a ramp. And so we know we're looking for our final velocity, and we set the initial velocity equal to 0. So whenever we're solving for this type of question, we know that all of the forces are in the y direction, because in this case we are not including friction. So the only forces are mass times gravity and the normal force. So in the y direction we have mass times gravity, and we set it negative so that we can bring it over to this other side. And then we have the centrifugal force, which is equal to the normal force. So we use that instead of just putting normal force, because we don't know what the normal force is. So that's equal to the mass times velocity squared divided by the radius, and we set that equal to 0. And then so we add mass times gravity to both sides. We have just the centrifugal force left on this side, and then we multiply this side by r and this side by r. Radius on this side cancels out. We're left with mass times velocity squared equals mass times gravity times radius. And then the masses on either side cancel out, so we are left with velocity equals the square root of gravity times the radius. So whenever we plug that in, this should actually be meters per second squared. That makes it a little easier to understand how the units cancel out, because we'll have meters times meters, and that would give us meters squared, and then we already have seconds squared, so that would be meters squared per second squared under the square root, cancels the squares, so we're left with just meters per second in our units. And that final value is 9.81, it's meters per second squared, is our acceleration due to gravity, and then our radius of 55 meters, so this value is 23.2 meters per second. And that's how fast you can go over the top of this hill without leaving the ground.